Hello and welcome to another episode of Azure User Group Sweden. My name is Håkan Silvernagel and I'm going to guide you here through today's session here, which is about how does a coding agent work. So we have an interesting speaker here from Sweden, Tore Nestenius, so we're going to get to know him in a short while here. So unfortunately, Jonah Anderson, who is the founder of our meetup group, couldn't be with us today, but she will be with us in the next time here. But before we start, I would just like to go over some of our code of conduct here for our user group. So we should be nice and friendly. We should listen with purpose and be thoughtful. We should be respectful to others. And we should seek to understand and not criticize. We should also be curious and open to share our ideas and be inclusive in our comments and questions. And if you want to know more about our code of conduct, you can follow this link that you see on the screen right now here. And if you are interested in presenting here at our user group, you can scan this QR code to get to our CFP page and you can add your call for paper. And you don't need to be an experienced speaker. Both me and Jonah are mentoring newcomers to the speaking scene. So you just need to have an idea about something that you are curious about and would like to present. And as always, we also have our digital fika after the session. You're invited to join a Zoom room where you'll be able to talk directly to our speaker, Tore Nestenius, and discuss anything that you found interesting here about the session here today. So I will be posting this at the end of the session, or you can just scan this QR code here right now. And a couple of weeks ago, me and Jonah were able to attend the Microsoft MEP Summit in Seattle. And during that summit, we were able to record in the Microsoft DevRel Studios a video, which is about how you can use Microsoft Foundry and MCP servers. So you can scan this QR code too, and you can watch it on our YouTube channel here. So, but now I would like to present Tore Nestenius, who is our speaker here today. So let us add him to the stage. Good morning, Tore.
Morning. Nice to be here and looking forward to do this presentation with you here today.
Yeah, we're very happy to have you here, and it seems like a very popular topic that you have up here for us.
Yes, it sure is. So.
Before we start, we just like to introduce Tore in a more formal way here. So Tore Nestenius is a Microsoft MEP in .NET, and he is a senior .NET consultant, instructor, and a software architect with over 25 years of experience. He specializes in .NET, ASP.NET Core, Azure, Identity Architecture, and Application Security, helping teams build secure, scalable, and maintainable systems. With more than 23 years of professional experience in software development and over a decade specializing in training developers, Tore is a seasoned expert in the industry. He currently operates as an independent consultant, delivering high-quality training, coaching, and consulting services. Yeah, so we're very happy here to have you back with us, Tore.
Yeah.
Would you like to say a couple of words here as an appetizer for our viewers?
Yeah, I mean, I'm happy to be back here. This is my second time at here in Azure, Sweden. So I always like to come back and share my experience and knowledge and what I've learned since the last time. So I'm very happy to see you here again. And we met for like a month ago in Oslo, where I also did this talk. So at the Oslo Norwegian.net user group. So it's always fun to share my findings and lessons learned.
Yes, so I can promise you, because I've seen this session live, that it's going to be an interesting session where you will be learning a lot here.
Yeah,
so
hopefully.
let's add here your presentation to stage, and the stage is yours, Tore.
Thanks. So how does the coding agent work? This is a very kind of interesting topic. So let's dive in. But maybe first present myself. So my name is Nestenius. I am from Sweden. At my day job, I'm a freelancer, I'm a teacher, instructor, and consultant, just as Håkan said. I also do blog frequently at nestenius.se about security, about .NET, about Azure, and now also about AI. I am also the co-organizer of .NET Skåne, a local meetup in the south of Sweden. So we also try to have monthly meetups in the south in Sweden. And if you have any questions to me after this meetup, feel free to email me at tor@tndata.se. So just email if you have any questions. But first, one important thing, and do ask questions in the chat, and always try to help. And it's always nice to get questions during my talks, and we can also take them in the session afterwards, in the kind of in the fika after this session. So just think about your questions, and I will try to address them as we go along. But we are in a AI revolution. I think it's hard to miss that is the thing is AI nowadays, and we are at the same time also we are all on a journey towards AI and learn more about it and similar things. And for me, the kind of revolution started when I saw kind of this post online from a friend from our Azure consulting company in Sweden that, and this is in Swedish, but in English it says that Claude creates chaos. The consulting firm stops charging for coding. So I really think that's kind of a sign that things will change now in the future. And other companies here in Sweden also said that we are changing our entire business to agentic first, and AI for everything. So we see that, and also we saw on GitHub some post some time ago that over 4% of all the public commits to GitHub were created by Claude Code right now. And I think it's a sign we need to kind of embrace AI and coding agents and what all it brings with it. But at the same time, maybe it's a bit hard to ask, these kind of questions here in this webinar. But the thing is that why you do this talk, and for me, as an instructor, I'm working on a training class for AI. I want to teach this kind of topic to everybody, and to also to help my customers, with the journeys towards AI and agentic development. But how should I teach it? And for me, just writing prompts is not enough. We can't just kind of teach coding agents by kind of create hello world app, and then a few moments later, let's create a C compiler that can compile the Linux kernel. I mean, I don't think that's the right way to kind of teach and also to learn coding agents. So what do we need to do instead to get a better feel for how a coding agent actually work? And for me, my kind of mantra is we need to have mechanical sympathy. And then you might wonder, what is mechanical sympathy? And for me, I got the kind of term by listening to a friend of mine, Martin Thompson, who did a talk about this kind of topic for some time ago, and also Martin Fowler did also post about it recently on his website. I do kind of try to post those in the chat here, so you can also see those links. Otherwise, I will kind of try to post those links afterwards. But so mechanical sympathy, what does it mean in reality? It means that we need to understand what happens under the hood. we need to know how the agent thinks and how it talks to the models. We need to understand the tooling and how the agents are using them. And we also need to learn what kind of drives the token cost and usage. And it's like driving a race car without understanding the engine. So from a developer point of view, I really like to build software that take advantage of a hardware that is aligned with how the hardware works or how the coding agents work, not trying to kind of struggle with it and trying to fight it. So I really kind of like to look under the hood to really understand what's make a coding agent tick. So that's a kind of a topic for the day, to try to understand how all of this works. So, and most of us started our AI journey by using the kind of ChatGPT in a browser. And I think we've all been there, asking questions, asking a model to generate code for us. And, it works, but it doesn't really scale at an enterprise level. We need to have a better experience because now, if we use ChatGPT and copy pasting code, we just become a middleman between the browser and our source code. And that is pretty kind of both boring, it's kind of error prone, and we are just kind of a blocking factor in the middle here. So we want to somehow remove the human from the loop here. We want to be more, smart here. So we need coding agents. So we want, some coding agents, some application that we can instruct, please generate a FizzBuzz application, and we can talk to the AI model and then generate the application for me. And that's, I think, that's awesome. But to understand this, where should we start? And for me, the starting point is to start observing the traffic between the coding agent and the model to get a better feeling for how does it actually work. And to do that, I actually built my own coding agent explorer here. So this is an open source application that sits between Claude Code and the model. And inside this tool, we can inspect and look at the kind of traffic between the coding agent and the model. So let's give it a try. So I will start the application, and just going to open Visual Studio here and start it up. And we have my tool here. So, okay, so at the same time, I can go back to my console window. I can enter Claude here. And I can ask questions like, hi, what is your name? And it will kind of, do some thinking, talk to the AI, and so on. But at the same time, I can go to my HTTP inspector to look at the different requests that were made. So this kind of is monitored in real time, so I can see all the requests going back and forth between the coding agent and the model. So in this case, we have a request here. I can look at the request and request body, and if I go down this body here, maybe I should be able to see my kind of prompt somewhere here in all this text. And I can also see the response. And in the response here, I can see something about, I'm Claude Code. I can see parts of it. And yes, just looking at the raw HTTP request, well, it works, but maybe not so good experience. And a better experience is to use my conversation view. So here, in this tool here, I can zoom in a bit here. I can see my prompt. Hi, what is your name? And then I can see the response from the model here. I'm Claude, made by Anthropic. So it's awesome. So this tool allows me to in real time observe how the coding agent kind of behaves and works under the hood. And if we were to do another kind of query, I don't know what the day is it today. I don't know if it knows that, but we can see here in real time how it kind of communicates back and forth. So we can see what day is it today, and we can see the assistance response here. Today is April 12th. Maybe not so correct, but I don't know. Maybe it is, yes. So that's good. So we have this tooling here, so we can look in between here. But then the next question is, how does the agent access the source code on my computer? Because, I mean, we have the model here, and the model here can't talk directly to my local hard drive. And so somehow we need to allow the model to talk to my local files. And I mean, if I were to kind of ask the model in coding agent, why is my application not working? It would just say that, hey, I can't see the code yet. Please paste the file of your program class, because it does not have a direct access to my source code. So how do we solve this problem? So what we do is that we give the coding agent a set of tools. And okay, so we do have a set of tools available in the Cloud Code coding agent. So we have tools for file IO, in doing web search and web fetch and run bash commands and similar. But how do we, let the model use those tools? That's the challenge. So what we do is that the coding agent will, in the request to the model, include kind of instructions for, if you want to read a file, please respond with read file and the file name. So then we send this to the model, and the model can reply back with, hey, read file program class. So the coding agent will then detect that command and read the file from disk and then upload it back to model. And here we see that we have some kind of typo here. And then the model can respond back with the solution to my problem. So all coding agents works in a similar way. We describe the tools we have available, and then it's up to the model here to choose which tool to use. So we can see this in my coding agent Explorer. So in my case, I can send up a prompt. Please create a simple FizzBuzz application in C# and some other kind of instructions. And so I can copy that prompt. I can go to my Claude code here. Let's clear this. So I can go here. I can paste in my prompt, and so create a simple FizzBuzz. I send this to a model, and we can just say yes to everything. And here in the conversation view, we will see all those requests that it goes back and forth. We can observe this kind of communication. So let's go through the communication here and look at what actually happens. So we have here my initial prompt, create a simple FizzBuzz console application. I will zoom in a bit here so it's more clear to see. So here's my initial prompt. But inside this request to the model, it sends other things as well. First, we have a system prompt. And this one is more general kind of instructions for that describe what is Claude Code in this case. So it includes the rules, the definitions, and how you should behave. And when it does or doing tasks, it's about executing action with care and other things. But we also include a set of tools, tool descriptions. So in my case, it includes tool descriptions that is sent to the model. So we have one, for example, let's say read a file. So for the read a file tool, here's the description. So it's just another prompt that describes, if you want to use the file tool, here's how to use it. Parameters, rules, and what you can do and not do, and things you must do, and other things. There's also kind of a bash tool. So if you want to execute a script or a bash command, and here you have, important things for file search and content search and read a file and, communication and other things. And these instructions can be pretty kind of extensive. And all of that is included in the kind of bash tool. So for each tool, there is an extensive prompt included. And if you want to write a file, here's a prompt for that. So we send this tool list, tool descriptions up to the model. Let's kind of just collapse this window here, like that. So with my kind of initial prompt, we send up the tools, the system prompt, and as a response, we get a tool request. So it wants now to use the tool write tool. So it wants to use this, it sends back the tool write tool request. So it wants to write this file in the FizzBuzz folder and FizzBuzz project file, and then also print a program class here. So that's the response back to the coding agent. And the coding agent will, detect that, try to execute it. So it will send back to the model the tool result, the result of executing these two tools. So in this case, it succeeded in creating those two files, and then the model can reply with both files created, and what did we do, and here's how to run it. And this information that we see here at the end is the same as we see here in my console window, like that. Let's zoom up here. So that shows how the coding agent talks to the model and how it can describe what tools are available, and then it is up to the model to decide which tool to use. But we also have another concept called MCP, Model Context Protocol. So what is that? So I mean, and why do we need it? Because first, when the web came, we created web pages, and we created web pages for humans to consume. There's images, CSS, JavaScript, and all of that. And then we had the API revolution, because we had mobile phones, we had complex front-end applications, and we need to integrate with other systems. So we needed the APIs. But if we already have APIs, then why do we need MCP? And the problem with APIs is that they are pretty hard for a coding agent to use, because they're not that self-descriptive. Sure, you can get an open API or Swagger 5 that describe the API, but it doesn't really describe how to use it. So we need something else. And MCP are like an API, but optimized and specially made for coding agents. And an MCP allows the agent to discover what is available, and it's better kind of suitable for kind of AIs to talk to kind of an endpoint. So the MCP specifies the kind of protocol between the agent and backend servers. So an MCP server can either be HTTP based or a local application that you communicate via SD, standard input output. So in a coding agent, your MCPs just becomes another set of tools in your tool belt. So what happens is that in the request to a model, we also will include MCP tool descriptions. If I want to search or if I want to get something, those are also added to in the request to the model. And then, as a response back, it will kind of, maybe if it decides to use one of those tools, it will then ask the coding agent here to talk to the MCP server. And the key here is that the model here will never talk directly to your MCP server. It always goes through the coding agent and then to your MCP server. So in our case, we can actually register an MCP and see those, tool calls in the coding agent. So let me go back to the to my application here, and I will go to this tool here and clear this listing. So what I will do here now is, so in my case, I do have a GitHub repository, and I will show it here on the screen. I do have it here. Just let me find that browser screen here. So I do have a GitHub repository. It's called a Cloud Debugger. It's an Azure exploration tool that I developed and open sourced. I now want my local coding agent to talk to this repository. So the question is, how should I do that? And one option is to use a service called gitmcp.io, and all of those links will be available at the end of the presentation. And this is a service that allows you to make any public repository an MCP server. So in my case, I can just, if I here, just kind of, I'm just going to copy one URL here. So basically what I can do is to take my public GitHub repository URL, just change it to gitmcp.io, and then I get an MCP endpoint. And if I go to this endpoint, I'll receive the following information. So this is an MCP endpoint for this public repository, and I can connect to this server using this URL. So that means that I can, in Claude Code, if I go back to my console and start Claude, I can, in this case, for example, ask a question like what are the main features of, we go to the, here, what are the main features of the Cloud Debugger? So what we actually trying to do here now is, just going to give you an overview, is that I want to send a prompt to the model. What are the main features of this GitHub repository? And the model here will, so in the request, I will include tool descriptions for this MCP tool. So that is sent to the model. And then the model will ask Claude Code to use that tool, and then the Claude Code will talk to my MCP server and get the information. And in this case, I get a response back here, a summary of that repository. So that's good. But I can also explore this information in my coding agent tool here. So what happens here is that we can see here in my tool's description that here are the tools, the MCP tools available. So there's one for Authenticate, there's a kind of a Google Calendar, and then I do have the Cloud Debugger MCP tools in this case. So I can expand one of them and be kind of go back up here. So for example, fetch Cloud Debugger documentation. So here's a tool that the model can use, and here's the kind of general description for the purpose of this tool. So I sent this request to the model. What are the main features of a Cloud Debugger? And in this case, we see here that the model responded with, please use this MCP tool, fetch Cloud Debugger documentation. We can also look here if there are any parameters. There's none. So the model responds with this kind of request to the agent, and the agent talks to the MCP server. It downloads the README file, so it's a markdown file from the public README file on that repository, and it sends it back up to the model, and then the model responds with a summary of this project. So we can see how those kind of the interaction here is in this tool as well. So I think that's pretty neat that so MCPs are just another set of tools available for the model to use. And this tool here shows that Claude Code in this case will include tool descriptions for those MCP kind of services and functions. And if you then want to register this endpoint, here's the command how to register that MCP server in Claude Code in this case. So I think that's good. But okay, so MCP is good, but so far we have seen how the Claude Code uses the MCP tools, and okay, that makes sense. But at the same time, it would be pretty kind of interesting to also see the traffic here between Claude Code and the MCP endpoints, and how can we inspect that traffic? So of course, I fixed that as well. So we can actually add the coding agent here as well between the MCP and Claude Code. So let's see this in action. So the thing here is that I register that my coding agent is a local HTTP-based MCP kind of endpoint. And then I point coding agent to talk to this one. And by doing so, I can actually capture the MCP traffic between the coding agent and the MCP server here as well. And in my tool, it looks like this. So I do have a separate tool here, MCP Observer. And if I go into this one, I can see the kind of previous request that was made. So we can see that there was first an initialized request, then some notification, and then it makes a tool list request. It asks for all the tools available in this endpoint. And in our case, we do have 4 different tools here available. We can get the documentation, search within the documentation. We can search with code base or get a specific URL, for example. And then when I asked it about this project, it sent a tool used to the MCP endpoint, fetch Cloud Debugger documentation. And then as a response, we see it here that we return some JSON. Here's the kind of documentation, the README file from that project. It is returned back. So this tool allows us to see both between the coding agent and the model, and between the coding agent and the MCP servers. Because I really believe in, if you are going to master and understand coding agents, you need to understand how they talk to both a model and the MCP servers on both sides here. And this is the same principles for both Copilot and other coding agents too. I'm using Claude Code in this case. I do actually plan to create one version of the Coding Agent Explorer also for Copilot. It's on my to-do list. Currently, the tool only supports Claude Code. So that's good. Hopefully that makes sense. So when the coding agent talks to the model, there are kind of three main pieces, and we have seen the kind of signs of those during this presentation. So we have the system prompt, we have the tools, and we have the messages. So the system prompt is the kind of LLM's general instruction set. It kind of describes what the coding agent is, expectations, and what it should do, and so on. And this one is included in every request. We also have a tool list. So we have this list of tools, and for each tool, it includes a prompt that describes how to use it and when to use that specific tool. And that also includes MCP kind of endpoints. And then finally, we have a prompt and the message history, your context window. So in my tool here, if I go back to the tool, to the conversation view here, we can actually see the kind of token usage. We can actually see that the system prompt is about 26,000 characters, and the tool description in this case is about 80,000 characters. So all of this information is sent back and forth between the agent and the model. And if you want to really go deep here, there's actually some raw details here as well, where you can see the raw request and response and events and token usage and also caching behavior and similar things, and also statistics. So you can actually try to estimate how many characters we type is kind of represented by a token. So you can see a lot of kind of internal details about how the agent works with the model. But the important thing is that all of this information here that we see here, system prompt and tools, and your kind of context history is included in every request, and eventually it can grow and become pretty big. So that's a drawback. And I can skip that one. Another thing is that we have hooks. So hooks are a way to extend Claude Code with additional functionality. And so hooks are commands that can be executed when an event occurs inside Claude Code. So it can, for example, be used for this one hook called pre-tool use. So before Claude Code wants to use a tool, it can invoke the pre-tool event. And here we can use this hook to, for example, enforce security, that if it tries to access a specific folder, I can, for example, deny it or allow it. I can do logging, I can do trigger automation, or notify external systems, for example. So an example could be like your Claude Code wants to read a secret file, like secret.key in this case. And then a hook could be that, hey, you may not. And then it can block Claude Code from reading that specific file. So that's one usage for the hooks in Claude Code. And Claude Code, provides a extensive set of events to hook into. There are kind of tool events before a tool is used, after a tool is used, and if a tool failed. We have sub-agent events, where a sub-agent starts and stops. We have session events when a session starts and ends. We have user interaction events. And we can hook into all of those hooks if we want to. But how can we explore those? And of course, I provide a tool for that as well. So I do have a separate column executable file. I can register it in Claude Code. So each time it wants to use a hook, it will call my hook agent, and it will then pass that information to my coding agent Explorer in this case. And if I go back to my Claude Code here, I can, for example, go into hooks, and I can see that I do have a little set of tools and hooks, implemented here. And I can actually see those hooks in this conversation view. So I do have a checkbox up here. So I enable it, show the hook events. And here we see that it kind of shows all the kind of additional things. So let's go to the top here. So we have a session start event. We have a user prompt submit event. And I do have, for example, pre-tool use. We have to zoom out here a bit, zoom in. And so this is a request that was kind of called my kind of hook agent, and it passed this information to it. So it can decide, okay, Claude Code wants to use this tool, and then my hook agent could, in theory, deny that and say, no, you may not use that tool because it's a violation of security or whatever. And then there's also post tool use that's triggered after a tool has been executed. And we can see the kind of details, the tool name, and also the tool response that kind of was sent, and I could capture that or log it or do something with it. So Claude Code triggers various hooks and events at different points in time, and we can see those events, and we can get notified about the various things that happens. So here's a notification hook that is triggered, and the message here is Claude is waiting for your input. So I think that's pretty neat. So hooks means that we have a separate agent, in this case, executable, that Claude Code will call each time a hook event occurs, and then it kind of will notify my dashboard that, hey, something happened, please record it and display it in my tool. So I think that's pretty useful. There's another thing called skills. I just briefly want to talk about it. So let's clear it and stop using those hooks. So I could, for example, say something like, okay, so let's do it like this. So I can go to my local folder here. And in this one, I do have .claude. I do have a skills folder here. And inside there, I have one skill named Sweden. I can go into the Sweden folder, and I do have one skill defined here. And we can look at what it contains. It basically contains three things. There's a name, my Sweden skill, and a description. When should the model consider using this skill? So it says that when the user mentions Sweden in some way, then use this skill. Oh, sorry. And the skill is basically then always respond in uppercase. That's my kind of stupid skill in this case. So let's try it out. So if I were to say, what is the capital of Denmark? It will write in lowercase. And you can, of course, also see the kind of all the communication here in the background. Copenhagen. I can know what is the capital of Sweden. And thanks. And after a while, we should see that it mentioned the skill Sweden here. It loaded the skill, and it responded with the capital of Sweden is Stockholm. So interesting. But how did the model, how did the coding agent use this skill, and how did the model, use this skill here? So what happens here, we can see all of that here in detail. So what happens is that the here we see that. So in the kind of what we call a system reminder here is a tag that is included in my prompt to the model. It includes various things like the following skills are available for use with the skill tool. Here's this one skill for update config, key binding help, simplify, use a loop, schedule. And at the end here, let's zoom in a bit, maybe zoom out. We see here, there's one skill. When the user mentions Sweden, use the Sweden tool. Okay, so that's all that is sent to the model. And remember, if we go back here to the local file, let me just kind of open it up in a text editor just to show you the skill again. So this is a skill that I described. And remember here is that we only include the description in the prompt to the model. We do not include the actual prompt. So it's more like a kind of summary. So the description here is what should be what describes the tool to model. And if this kind of description matches my prompt, then it can request to use this skill. But for now, we see that only the description is sent and the name of the tool is sent to a model. And then here, it wants to use the Sweden skill in this case. So it's like a normal tool. So it sends this back, use the skill tool named Sweden. And the model here now will launch skill Sweden. And there's a folder to it. And here is the prompt, the instructions for this skill, the actual kind of content of the skill. Because remember, and then we see the response here, capital is uppercase. Remember that tools, it includes the entire prompt for each tool when we use the tools, and that one can be pretty big. But with skills, we only include a summary, when to use it, and we can see it in the kind of context here. So we only include the kind of general kind of description for the tool, and then hopefully that matches the prompt. And if it does match and the model thinks it's a good kind of match, it can invoke that skill. So that's the benefit, is that we do not need to include all of those kind of prompt tool descriptions here in every request, because we see that those tools can be pretty big, like 80 kilobytes of characters in this case. So I think that is pretty kind of it's a good thing, good way to extend your kind of, your agent with additional skills, things that you maybe want to repeat often or similar. But the benefit is that we don't kind of bloat or overload my context with a lot of unnecessary tool descriptions. We just include the kind of a general kind of description of a tool, and then it can invoke it if needed. But finally, let's end with a last thing. Okay, so we have used Claude Code here so far, but how hard is it to build your own? And I really think that if you want to understand how a coding agent work, that you should write your own. And you can actually do that in less than 100 lines of code or 200 lines of code. And of course, I did it. So the basic coding agent is just a while loop like this. We have an agent, we ask the user for some input, we send the input to a model, and we get a response, and then we iterate over and over again. And of course, it would be a pretty stupid one, because it will forget what you learned in the previous prompt. So we need to have some history context. So the context is just a collection. So we have an instance of a collection, we ask for the input, we add that input to the context, we send the entire context to the model, We get the response, we remember the response, print the response to the screen, and then we loop back here again. And that's it. That's a coding agent. But we also want tools, because here we can just kind of chat with it like a ChatGPT or Copilot, but we want to work with source code. So tooling is very kind of simple as well to add here. So we basically add a check here. Did the agent want to use a tool? I mean, based on the response here, is this a tool use response? And if so, process that tool request and then send the response back and then continue the loop here. And that's it. That's a simple coding agent. And I actually wrote one, and you get a link to it in the end of the presentation. But I made one here in C#, very basic one, simple one. And basically, it's just a loop here. We get the input and send a message, and then we have tool use. So how do we define the tools? Well, in this case, I have defined the tools in a kind of structure. It's a list of tools. I have one read file. It has a description, how to use it, and some parameters. And there's a write file tool and a list files tool here. And then basically I do have a switch statement. If the model wants me to use the read file, then we solve the path. Does it exist? If so, read the file. If I want to write a file, write file. I mean, that's it. So we can actually run it and see it in action. So I do have a sample prompt. I do like the FizzBuzz example here. I copy that one, and we kind of go to and write to the My Agent folder here. So I start the application, and I will also go back to the console, and we go to My Agent folder, and currently this folder is empty. As we see here, there's nothing here. And I can, go to my C# coding agent. I can paste in my kind of prompt. Maybe I did start the wrong project. I'm going to start the other one. Have to be. So I have my agent here, and as proof, my folder is empty. I type in my prompt here, and I can here in my tool now see the interaction here, how it kind of communicates, sends back and forth, tool usage, and all of that. It's a bit hard to kind of visualize here in the presentation, but we can see the communication back and forth, how it wants to use the tools. Here's the tool calls, write two files. And if I go back here to the other folder and type dir here, we see the FizzBuzz application, and I could do .NET Run, and that should work. And we get kind of FizzBuzz output. So in this case, I do have two kind of implementations. One that is more pretty and more verbose. This one is about 300 lines of code. And I also made one more minimalistic kind of version here. It's more compressed. And that one is without kind of fancy console output. It's about 200 lines of code. And you have a fully functional coding agent that you can work with and, write code and troubleshoot code with. So I really believe in trying to understand it, create your own debugger tool, and I really think it's a good exercise to learn more and get a feeling for how a coding agent behaves. So next step, do explore the coding agent explorer. Do explore the public content on this link here below, or in the scan the QR code, and everything is online on my GitHub repository, and that's it. And do follow me on LinkedIn if you want to follow my work. That's it. And I'm happy to join the Q&A room afterwards to answer all your questions.
Okay, Teresa, thank you so much. It was a really interesting session. So we have a couple of questions here from our audience. So here is first one from Nikhil Pal 8904. He says, what is the accuracy percentage of coding agents compared to human?
Well, I mean, it's a good question. I believe the models that we do use get better and better for every day. So, and I think today they're pretty impressive. And I really believe they're kind of, competent developers. But of course, it's all about how you prompt them and how you instruct them. And so I really believe in how you express your specifications and guidance and instructions to the model. And if you do it right, you can get excellent kind of response back. And of course, if you do write bad prompts or don't use it in a good way, then of course you will have a pretty disappointing output. And that's why I talk about this mechanical sympathy, because I really believe in understanding the tooling, understanding the principles behind a coding agent, and work with the system and not against it. And I really believe in this principle, and so do check it out, the principles of mechanical sympathy.
Mm-hmm.
Any more questions?
Yes, then we have a question again here from the same user, Nikhil Pal 8904. He says, what about that AI can hallucinate and trust issues? What are your thoughts about that?
Yeah, I mean, it's once again, I think it's all about understanding how you use the coding agent, because if your context gets too big, I mean, as I said before, you do include your entire conversation history, and when the value sent too much history back to the model, it can get confused, because maybe you're talking about 5 different issues during your conversation, and of course that can confuse everybody. So I really believe in clearing your context often, because clearing your context and start over, I think that's a good practice, because with a clean, small context, you can get a much better result compared to just bloating with kind of all your kind of questions and kind of issues. So context management, I think, really is the key here.
Okay. And then I think that's it for our questions here. And as I said here at the start of our session, we will also have Zoom Fika here, so you're free to join that. Let me just hide this thing, and let me post this thing here in the chat here. So like that. And also maybe interesting here for our viewers. Do you have any public sessions coming up in the near future, Tore?
Only kind of local meetups. I don't have any conference talks scheduled yet, but hopefully I will be at some conference as well. But I do have a few meetups both in Copenhagen and in Gothenburg and coming up, and also probably Stockholm as well. So there's a few topics. There's a few kind of presentations coming up. So.
Okay, great. We also got here a comment here from Peter Lindström 7694, who says, interesting. Thank you, Tore.
Thanks.
So with that said, I think we will end the stream here, and we hope to see you in the Zoom meeting. And we just wish you a very nice weekend, and hope to see you in our next session. Thank you so much.